Okay, any ideas? Let's look at the problem again. What are the things that are given to us here? So we know the pressure also. The pressure is 1 atmosphere. And we are also given the partial pressures of SO2 H2O over solution. Right? Equilibrium. The gas that is getting out is at equilibrium. So can we use this data in any way? It's in equilibrium now, going out. So SO2, H2O, we know the equilibrium concentration or equilibrium partial pressures. Yes?
We can figure out the mole fractions from
There you go. Right? So because we know the total pressure and we know the pressure of each of these vapor pressures, and it is at equilibrium, there is no question, so which is at that vapor pressure, so we can calculate the mole fractions of each of these species in the exit gas. Right? So let's do that, folks. I want you to start doing it, not just looking at my handsome face. I know, I look handsome, don't I? You all want to look, but we got to do these problems. Okay? So let's do this actually here. So how can we do it now here? We are trying to figure out the YH2O, and now we can write one thing here very clearly. PH2O is given as, let me write this here. PH2O is given as star, or vapor pressure is given as, equilibrium vapor pressure is given as how much? Do you guys know? 136? 31.6. Very good. 31.6 millimeters, right? So what is the total pressure there? 760. Okay, so now this will give me YH2O, right? YH2O is equal to now what? How much? 0.0415. Any confirmations? Can we calculate, let me do this here. Can we calculate YSO2 here? YSO2 is equal to? Now use the same logic. Equilibrium vapor pressure of SO2 given to us. What is that value given to us? 176 mm, and divided by 760 will give you, what's that? 0.232. I have to get here an extra slide. How in the world can I do it? Come on. Holy moly, that's gone now. I don't know what happens this here. Okay, let me write here actually. Let me solve here. Okay, so what did we get here? Y H2O is equal to 41 and 415. Y SO2 So what else do we have here? Y air, because there is some air, there is some SO2 that did not get captured is going out, and then there is some water vapor that goes out too. So air should contain basically three components. So Y air is, because there is no other component, 1 minus YH2O minus YSO2 will give you 0.7 0.72. Holy moly. Okay, this is pain to write these things. Okay, so now we have YH2O. So what else do we actually need to know from this? What are the other variables that we were putting into the system there? What are the other variables?
We know the feed rate. Fair.
This we know that there were 100 pound moles, and we said ML1, which is the liquid, this is the water that is going out. Coming out is Ng2, that is the gas coming out, and then ML2, liquid coming out. And this gas contains this YH2O, YSO2, and Y air. I don't know if you can read this, but these are the components which we know. So what are the three things that we don't know here right now? This one, and this one. All right? You all agree? This one, gas, number of moles of gas getting out, right? There are three variables here which we don't know. We have to calculate. And how many independent equations can we write?
3.
What are those three?
H2O balance, SO2 balance, and air balance.
Air balance. So we have three species in there, and no chemical reactions, so three species have to be counted. Whatever is going in has to come out. So three species balances, and there are three unknowns here. Can you guys solve that?
Yes.
Yes, right? Three unknowns, three equations. So I'll leave it to you to solve that. Promise me that you're going to do this at home. You're not promising, right? We'll try.
What's the right answer? I mean, what's the point of doing it if we think we do it right?
We can compare it tomorrow or next class. That's the goal. You guys do it, and I'll give you the right problems, actually, or the answers also. Okay? We can compare. I'll do that too. I'll do my homework at home, and we'll get that. Now, because it's going to take time, the class time, I don't want, but three unknowns and three independent equations. Basically, it's very, very, straightforward, but you have to do it. Okay.